This is netstack.fm, your weekly podcast about networking, Rust, and everything in between. You are listening to episode 3, recorded on the 29th of August 2025, where Glenn has a conversation with Chris Batterbee, co-founder of Metoro, a company providing instant in-depth observability for services running in Kubernetes.
This is another episode and another week of netstack.fm. Today with me is Chris. Welcome.
Hey Glenn.
Thank you for accepting our invitation. Today we will talk about Opentelemetry, about Metoro, the company that Chris co-founded. What's your background story, Chris?
I'm a software engineer primarily. I've done a few different things. I worked at Palantir out of university, doing a lot of Kubernetes stuff there. So that's mainly around scheduling really large compute jobs. How do you get those to run efficiently over large distributed clusters, primarily in Kubernetes, but with some other schedulers as well. Since then, I went on to found Metoro, which does observability for Kubernetes. How can we make observability in Kubernetes the easiest thing possible?
Can you maybe tell a bit more about that experience with Palantir?
Yeah, so Palantir runs a lot of different compute jobs. A huge amount of it is based on Spark, so a lot of big data stuff. So you have huge amounts of data coming in. You want to run custom code on that to produce different data artifacts out the other side. And a huge way of doing that was Spark. So I worked on a team which was responsible for orchestrating that compute. Essentially, we get things in, which are custom applications, but based on Spark. We then need to make sure that that is ran across large compute clusters, that we scale up effectively. We handle any issues with communication, nodes going offline, nodes coming online, and doing the whole orchestration flow around that. And while I was doing that, I realized that you need pretty good observability to be able to drill into things, figure out exactly what's going wrong in certain situations. And I thought there was a lot you could do there without having to do a lot of manual instrumentation. And that's really where Metoro was born. It's can we use some cool technology, which is primarily eBPF, which is some tech inside the Linux kernel, which allows us to automatically instrument a lot of applications for you.
It's pretty magical, and as you said, there's not a lot you have to do out of the box. It just seems to work. Now, at what point did you add Opentelemetry to the mix?
Yeah, so eBPF is great. Maybe I should explain a little bit about how that works in case people aren't familiar. But essentially, it's some technology in the Linux kernel, which when certain events happen, you can run code that hooks into it. Right? So in our case, we will monitor read and write syscalls. So whenever you write something to the network, we will inspect that write and see, does this match any protocol that we instrument? Like HTTP, MySQL, Postgres, all these L7 protocols. We will look at the data that's being written, and if it matches the standard specification for those protocols, then we'll know, actually someone's trying to make an HTTP call to a different service, right? And we'll pull that information out, we'll inspect essentially the headers, things about the body, to then produce a trace from that. So it means that we can do this for any arbitrary application because it's using eBPF and operating at the kernel level, so it means you don't have to use code. And that's primarily the reason.
Does this also work for TLS encrypted traffic?
So we do some TLS decryption stuff. So in that case, we'll actually hook into there's a bunch of standard libraries for TLS, and we'll hook the function calls to those. So it means that when you write into it the unencrypted content, we'll look at that unencrypted content before it gets encrypted. And that's how we can deal with TLS. So it works for a number of different TLS libraries, and thankfully, most applications use the same TLS libraries across the hood.
I suppose you mean things like KTLS, OpenSSL, stuff like that?
Exactly, yeah, boring SSL, these sort of things, yeah.
And then let's say someone would use an entirely different implementation of TLS, like Rust TLS. Would that still work?
Yeah, so for any new implementation of TLS, we'll have to do some additional instrumentation on our side, but thankfully there are very few TLS implementations, like boring SSL is the big one, which is using Rust in my experience, but there are some other ones coming up as well, I think.
What can people expect already out of the box if they have this? What can they expect to see or do with that data?
Primarily, you'll be able to see, all these services, every single call they make to any other service, as long as they're using a supported L7 protocol, so using, gRPC, HTTP, Postgres, MySQL, we have a bunch of other ones. As long as you're using those protocols, you expect to see pretty much every call that's being made between those applications. And that's a really great starting point. But to your question on, why do we bring in Opentelemetry and why do we start using Opentelemetry as well? It's around joining those together. So what we can give you with eBPF is the individual calls, right? So in the terms of tracing, that correlates to an individual span, right? So you'll be able to see microservice A talks to microservice B. That normally happens in a chain, right? So A will talk to B, which will then talk to C, and maybe that will talk to a database on the back end, right? So when you want to tie all those together, that's very hard to do at the level of eBPF because a lot of the time you do things like cross-thread boundaries. So like, let's say, something comes in like a request, it gets put into a pool, and then that pool then makes a thread pool, then a thread on that thread pool then makes another request out. That tracking across thread boundaries is really hard to do at the kernel level. So when you want to start to do this more intricate instrumentation and you want to get really detailed and add your own spans, that's when Opentelemetry comes in. And really the idea here is that we give you the base stuff, and then when you want to add more specific instrumentation on top, that's when you can use Otel.
And of course, a lot of languages these days, they also manage their own threads. Like they might at the core use the operating system threads, but then within those threads, they might do all kind of like what they call green threads. So I suppose you will anyway never have access to those.
Yeah, you can do some funky things where they're using like a VM. You can try and traverse the memory of the VM to understand, well, what are the actual language level threads on top of the actual threads. And there are some cool things that people do, actually. There's a very interesting project called Deepflow, which tries to do distributed tracing using eBPF. And they do that by tracking threads. So it's like if, a request comes in on one thread and the same thread makes that request out, they can link those two things and say, okay, well, this is part of the same request. And they can also do that for Go, which has its own implementation of threads on top. So like they can do certain things like this, but it starts to get really tricky when you have like, things explicitly crossing thread boundaries as well. Like that gets really tricky, which is why at that point, you're often better doing something yourself rather than relying on auto instrumentation.
So we, for starters, are very excited about Opentelemetry because we've all run like production setups and things go wrong. It's these kind of edge cases which used to be hard to reproduce, but then once you have a telemetry at runtime at any time, they just become very visible. At the same time, it feels like still a very immature ecosystem. How was your experience with that?
Yeah, so Opentelemetry is it's a very verbose system. As an implementator of it, it takes like a lot of work to translate between different formats. There's a lot of different libraries. As someone using Opentelemetry, I think the experience is much better. But as you mentioned, I think like your experience is coming from Rust, right?
My core focus is definitely Rust.
Yeah, and I think depending on the language that you're using, they all have their own implementations, and they're all at various stages across this sort of stable life cycle, right? Where it's like some are been around forever, like the ones in Java. Python's pretty good, especially ones where auto instrumentation is possible. So a lot of the things where you have non-native binaries like Python, where it uses a VM, they can do very good auto instrumentation for you. But when you start using languages like Go, for example, or like Rust or C++, something which is compiled, you have to do a lot more yourself. And at that point, it can become quite intense to implement that as like a single developer, or it requires like a pretty big org-wide effort to sort of say, okay, we are going to use Opentelemetry and we're going to use it properly.
What's your typical kind of customer and what languages they usually work with?
But where we really shine is when you have like a pretty large microservice system across like different languages, right? So because if you want to implement Opentelemetry from the start, you can do that. And if you have like one consistent language, it's much easier to do that across like all of your services. Whereas for a lot of our customers, they use many different languages. And where eBPF really shines there is that it can get you that base level of instrumentation across all of them without you doing any work. So our average customer would probably have maybe 5 different languages used across, I would say, maybe 20, 30 microservices. And at that point, they can get pretty decent instrumentation with like a 1-minute install.
Okay, and so given it's eBPF based, does it also mean that even if someone doesn't use Kubernetes but is just running Linux on the bare metal, are there any customers like that and that still make use of your services?
So you can do that, and so our node agent will run on those machines, but for the most part, we focus specifically on Kubernetes. Just because we can get a lot more information as well, because you can combine the eBPF stuff with like the actual like metadata provided by Kubernetes, like around pods, nodes, these sorts of things, and you get a very rich experience out the other side of that. Whereas if it's just on a host, you have a lot of these processes which aren't necessarily linked to something you're running in production. Maybe they're just sort of like system daemons, things like this. And at that point, it gets harder to distinguish, well, what should we actually be monitoring?
Okay. Do you have your own implementation of then the Opentelemetry ingester, or how does it work?
Yes, we receive like a number of different formats. So at like an architecture level, we have these node agents, and these are the things that live on each of the hosts inside a Kubernetes cluster. And they collect the telemetry, they generate all the stuff via eBPF, and then that sends to another component inside the cluster called the exporter. That's done over the Otel protocol. So in this case, we'll use like the Otel trace protocol to send traces, same with logs. And at that point, you can start ingesting your own stuff as well. So that component will take stuff from our node agents, and it will also take any of your own custom Otel stuff that you want to send to us. Then that will all be forwarded to our ingesters, which live in the cloud or on-prem, and they can receive a number of different formats. And like one of those is Otel.
What are some of the other formats you support?
Yeah, so it's primarily around like metrics, things like this. So I used to support like Prometheus, a few other ones as well. Like if you're using logs like Vector, some of the things like this, yeah. But around traces, we try and translate everything in the exporter to Opentelemetry and then forward that on.
Okay. And how good is it working so far to combine metrics and tracing and spans and all that stuff?
Yeah, so metrics and traces are an interesting one. Because when you sort of think about, okay, well, how do you debug an issue? At least the flow that I tend to go through is like, okay, well, you first see something is generally wrong in metrics, right? And then you want to go from there, okay, well, where exactly is something failing? Because you may see in your metric, okay, well, there's a spike in 500s in this service, but when there's many dependencies, well, how do you solve that? At that point, you then want to try and find a trace. So you probably hop to the trace view and say, okay, cool. This trace from this service is failing. And then that will give you the whole distributed trace, which will isolate it to an individual service for you. And then at that point, ideally, you can see the logs for it, right? That's the sort of overall flow. It's like metrics, traces, logs. Traces to logs is like normally pretty good because when you emit a log, you can include something like a trace ID. And if you include a trace ID inside of the log line itself, it's very easy to correlate those. You can just search for that attribute inside of your logs and you'll find it. Metrics to traces tends to be a little bit harder because there's either a one-to-many relationship or in general, it's like they just don't track these things across like metrics to traces. So I would say metrics to traces is the hardest part, but traces to logs is much easier if you support it. But you have to emit that from your log line, which some automatic tracing libraries do. So if you're using something like the OTel libraries for Python, they'll automatically include the trace ID in any logs where there is a trace associated with it.
Yeah, it's tricky, especially also the fact that there's a lot of limitations and constraints around how much data you can put into the metrics. Like, for example, with your tags, with your labels. And so I imagine that adding something as unique as a trace ID, that would completely explode your metrics data.
Yeah, the dimensionality problem is pretty big with metrics. I think like in general, this is why traces and logs tend to be quite nice because they don't really care about cardinality too much. I mean, like when you index them, you tend to index them on very low cardinality things, and it allows you to add really high cardinality stuff like a full error message, right? Like that tends to be the best way of solving problems. It's like if you have the full stack trace and you embed that inside of your trace, then you can just see that immediately when you search for a distributed trace. I think traces and logs is the most mature part of that. There needs to be a little bit of work done to combine that metric to then give you a trace at the other side.
Is it a concept where as you are emitting these metrics from a specific part in your code, which is also a location where you're emitting spans and logs, where you would add aggregations of these metrics at that point as part of the span that you create? Is that something that people do or that is possible?
I mean, I think you could do it. I think like, so for example, if you wanted to emit like a trace and then go and get the value of a metric at that point and then add that as a attribute, you could do it. I mean, there's nothing stopping you from doing that. Like you could introspect the OTel, like whatever library it is you're using to emit those metrics. I find it's very rarely done in practice though. I've never seen that be done. I think there are some metric formats now which allow you to embed specific trace IDs inside of them as exemplars as well. And I think like that might be a good part of the metric and you can do a scan for it later when we're emitting them. I don't believe I've seen anybody ever actually use it.
Is it because it's very new or is it because it's still like very experimental?
That's a good question, actually. I actually don't know why I've never seen it be used. I think it's one of those like kind of like niche things that sort of goes like overlooked for the most part when people are implementing stuff.
Gotcha. Do you also in close contact with the Opentelemetry organization?
So we're actually not. I mean, I'd love to talk with them more in general. But no, we've been very much Opentelemetry exists and like is the standard that everyone's using. So like let's get involved and implement it on our side. But we've not really had too much scope in shaping the actual direction of the initiative at all. But I'd love to get involved sometime. That'd be pretty good.
Okay, yeah. I imagine as you as a company are pretty close to the ground. Like I can't imagine much better players to give feedback on how it's actually like being used and where maybe the pain points are.
Yeah, we'd love to do that, and I think like we'll try and get more involved with the community as we grow as well. So we're a fairly new company. Resources are always tight. We have to sort of decide, okay, where we're going to spend our energy. Ideally, as we grow, we can sort of start to give back a lot of the experience we have around Opentelemetry back to the community. That'd be ideal.
And so right now, you're very much eBPF based, and while I think Kubernetes will still be around in 20, 30 years, I imagine, what is also happening is the entire WASM community and WASI community, where folks might have some kind of orchestrated services, like very beefy services that host a lot of different WASM services that you can just hot patch. Would that be something that you can ever support?
Yeah, that's a good question. I haven't actually looked into WASM an enormous amount, but like essentially like how does that work in like practice? Like in a production system with WASM, like is there essentially just like a bunch of like standardized nodes and then you sort of give your WASM components to it and they get compiled at runtime and they run? Like how does that work exactly?
Yeah, so you could compare it to like some kind of virtual machine, and you have like a host service, which is like running that runtime and executing the instructions. And so while you could run that in a Kubernetes setting, which I'm sure some people do, I imagine if you're especially like an operator or something that hosts a lot of these, there is little reason to do it. And so you would, at that point, we would go more back to my original question, I think, where you are more running on bare metal almost, because you will still be probably in a Linux environment, because that's at this point still the most common server environment. But you will no longer be in a Kubernetes environment, which makes me think, I guess, maybe your eBPF thing is still fine, because in the end it will still boil down to like kernel calls. And so, yeah, maybe it's not a big issue at all, but like I do wonder if there's like work needed there.
Yeah, I think like there probably definitely will be work needed. I mean, from our perspective, as long as this thing is making kernel calls at the end of the day, which pretty much everything is, and we can map the process ID of whatever is making the call to some service, then we can work in that environment. But we need to be able to just do those two things, which it sounds like we should be able to do, but I'd need to look into it more.
Yeah, got you. But then of course you also have once we touch the bare metal, you also have the Windows servers, which I get it is a minority, but it's still there's still a lot of money involved anyway there. So is there actually something like eBPF for Windows?
So I believe that there is a effort to essentially have an eBPF-like system inside of Windows. It was a CrowdStrike where they were running kernel modules in Windows, and essentially they brought down like a huge number of things because there was a bug. That sort of spurred Microsoft to say, actually, we need something like eBPF where people can still inspect system calls, but it runs in a VM, which we control, and therefore we can guarantee that it won't actually crash the kernel itself, right? They have a repository called eBPF for Windows. I'd actually be curious, as they sort of adopt more Linux-style stuff in general, like how many companies will choose to run Kubernetes on top of Windows machines. That'd actually be very interesting to understand that.
Okay, so also you are our first guest, which is not just a co-founder of a commercial company, but also was in a Y Combinator batch. How was that experience for you, and what were the takeaways?
Yeah, I mean, Y Combinator is great. And like I think like if you're ever thinking of starting a company and like you don't have the network in Silicon Valley, it's the best place to go. So it sort of gives you that network of, venture capitalists, investors, people that otherwise I would never be able to really talk to or get in front of. I had the opportunity to get in front of them basically purely because I went through YC. So the way I see YC in general is it kind of bridges the gap between Silicon Valley and technical people who otherwise don't have the connections to get there themselves. And I found that that's really useful. And then on top of that, you have the community, which is really nice as well. So I'm sure people probably know, but starting a company is a pretty tough experience. There's all sorts of things that go wrong all of the time. And having a bunch of people to share that experience with is just really nice. They're all the same point of view in the company. They're all going through the batch at the same time. So when you're there, you get to meet some great people, and they're, really good colleagues and people to talk to in general about stuff that's happening in your life that maybe other people who you've worked with in the past don't quite understand. So I found that to be really valuable. And the lessons they teach as well are just generally good for running a startup. I would say we're much further ahead now because we went through Y Combinator. So, super grateful to all the YC people.
Gotcha. And can you summarize from start to finish how the process was for you?
Yeah, so we always thought about founding a company. So it was myself and my co-founder, Tom. And so we were always brainstorming ideas, coming out, okay, well, what would be cool to do, right? And just like, it was very much on a whim, actually. I think like we came up with an idea completely different from the thing we're working on now, which is very common for a startup, especially going through YC, you'll often change your idea quite frequently. So maybe don't get too attached to the idea itself. But we had an idea for something. We just saw that YC, the applications were in process. So we just created an application. It was super short, like I think 1, maybe 2 hours max of filling in the application. And then we sort of forgot about it because we never thought we'd get accepted, right? The acceptance rate was low. And then we got an email just saying, okay, could you be here for a meeting at this time?
And where was here? Was that in the UK or?
No, so that was a video call at the time, and I think they still are video calls, but when we were doing this, it was coming off the back end of COVID, so a lot of the batches were virtual, and then the one that I did was one of the first ones that they were back in San Francisco for. But that's a virtual call. So yeah, we hopped on the call with our group partner, and they interviewed us, asked us a bunch of questions, and then we got the decision a couple days later. It was like a very smooth, very simple process that we really didn't expect to go through.
Very interesting. And then once you got accepted, how was it then? What was the expectation on their side? What were the things you had to go through?
Yeah. So they expect you to go to San Francisco. Essentially, the batch starts at a particular point in time. You need to be in San Francisco for that time. And it's a 3-month process. So the rough structure is essentially you have a 3-month batch. And at the end of that batch, you then talk to other investors and you raise more money. So Y Combinator themselves, they invest money. And then at the end of the batch, you then raise money from different investors. And the process is really along how can you get your company to be, in front of customers. How can you accelerate that process within that 3-month timeline? And it's structured in 2-week blocks where essentially you have a meeting with your group partners and you say, okay, well, these are the things that we plan on doing in these 2 weeks. And they give you feedback on whether or not that's useful or what you should be doing. You go away and you do that for 2 weeks and you repeat the same process and just do this iterative cycle of, saying, okay, we're going to do this thing. And then seeing if that worked or failed, this really quick hypothesis testing loop, you get to be in a pretty decent place after 3 months.
Okay, very nice. So that's pretty intense. And does it also mean they cover everything?
So you do that yourself, but you do that from the money that YC invest. So it's like you yourself don't have to cover that. Your company will cover that after they invest their money in it.
And are there also like a lot of networking events where you talk with other maybe founders or investors?
Yeah, all of the time. So the main sort of cycle is these sort of 2-week blocks. But on top of that, there's loads of events where they get lots of different founders, people from industry, investors to go to those events. And you can do a lot of networking there and just meet a lot of like really interesting people. So it's been, I would say like probably the most intense 3 months of my life, but probably some of the most rewarding as well.
Very nice. I mean, I'm also thinking, like, for example, right now, I'm a parent of 3 kids, so that's definitely not an experience I can go through, but it definitely sounds interesting for the future. I will keep it in mind.
I think, so there are parents who go through YC, and they manage to do it. I think, don't get me wrong, I think juggling both the company and kids going through YC is it's a tough thing to do, but there are people who do it. So it's possible. That's all I'll say. Yeah.
Yeah. I mean, it could be exciting, especially if you can take them with you and they can also maybe go to summer school there or some kind of exchange program. Could definitely be exciting. So you did YC Combinator. You say at the end you have to raise some money again. Is it because by that point you have talked to plenty of investors and so you know which kind of investor matches your profile or your goal? Yeah,
and I think as well, it's just a great platform for talking to investors. I mean, so this is the standard procedure for every YC batch. So every investor who's investing in these YC companies knows, okay, well, this is the time where all of these companies are going to go to, essentially ask for more money, right? To do the things that they need to do. So it means that in that time period, I think we spoke to, I can't remember the exact number, but I think it was around 100 investors in a few week block, right? And in terms of efficiency of time to raising money, that's great because a lot of people, this process can go on for a long time. But if you can talk to all these investors over a short time period, you can get that process done very quickly. And it's a pretty big advantage not to waste time doing that later.
Okay. And so because Y Combinator is both an investor and an incubator, they also have a stake in your company.
Yes.
How hands-off are they afterwards?
So it's really on you, I think, to decide how much you want their input. It is very possible to sort of fade off into the distance and then never talk to the YC group partners again. I don't think that's the best use of your time as a founder, and you're definitely not extracting the value from YC if you do that. But you can schedule meetings with them, pretty frequently. And in general, you'll talk to the community, or you should be talking to the community quite a lot. Because there's a lot of other people who have gone through exactly the same problems that you're facing. So if you're not talking to those people about how to solve those problems, you're essentially wasting time trying to solve them yourself.
Understand. But you are based now again in the UK. Is there also then a huge YC community within London?
Yeah, so YC London is pretty big. It's at least a few hundred people, potentially more. So there's a pretty big community in London. It's by nowhere near the size of San Francisco. San Francisco is, I want to say 95% of all people are in San Francisco, but then there are some smaller communities around the world.
Okay. And so if we dive back into a bit in the technicalities and go from business back to Opentelemetry, what are some of the pain points regarding that you are currently struggling with and that you would like to be changed?
Yeah, I think a lot of people have trouble instrumenting their apps with Opentelemetry when they have to do it manually. So instrumentation stuff is great, but when you want to start adding metrics, the overhead can be quite high to understand all the different types of metrics, how exactly you should use things. Well, what are the standard tags to add to all of your applications so that your provider knows exactly how to use your traces? There is a big learning curve associated with Opentelemetry, and I think really one of the best things that the foundation I think could do is, I'm not even exactly sure how to do this, potentially maybe adding an abstraction over the top, which makes it easier for people to get into Opentelemetry, which would be just essentially, here is something which looks very much like, Prometheus metrics that people are used to, right? Where they can translate very easily between the two. And it allows people to get into the ecosystem more easily, because when you're setting it up for the first time, there's just cognitive overhead, and it's pretty much exclusively with every customer that we talk to. It takes them a good few days to get used to that. And if you can reduce that, people will definitely use Opentelemetry more.
Okay. And how do you see it as a standard? Do you see it as that's definitely what we want to go for, or if one day there would be someone coming with something else, you would gladly jump on board with it?
So I think there are problems with the spec for sure, but I think it's good that there is a standard. I think like having like one main standard is really useful, especially just for customers, right? So it means that you can collect all this data on your side, and then if you're not happy with your provider, so let's say you're using us, or you're using, I don't know, someone else like Grafana, or right? If you're not happy with the service that we're providing, it gives you a really easy way to switch to someone else, because it's like the data is all standardized. So you just change essentially the endpoint you're sending data to, and now you can fully use another provider, right? That's really, really valuable to a customer. And I think like that's something which should exist. Whether or not it's specifically the OpenTelemetry specification, I'm not too invested in. But I think that having one clear standard is definitely the way to go.
And then often they say like platform is king. And so I wonder what stops something from like a G Cloud or an AWS to just eat your lunch? Because I imagine they already have everything you need. What stops them from doing it, and how scared are you of it?
So I think like fundamentally like they could, right? Like, I think like a lot of the cloud providers can eat the lunch of a lot of different people. I think a lot of the time it comes down to scope, like what it is they're willing to invest in, and the fact like how niche are you as a company, right? We have a fairly niche focus, and I think that gives us a little bit of protection where it's like it would require them to invest quite a lot of work to get to where we're at for potentially a market that they could be serving, like a bigger market somewhere else, right? So I think that that's potentially one sort of defense in quotation marks. It's not really a defense. And like, I think, am I scared about that? Partially, but I think as a startup, we have like other bigger problems to solve. And I think from our perspective, this is a good place to start. And there's a lot of other places that we want to go into. And I think the combination of the things that we build are quite hard to replicate, but fundamentally, yeah, someone could do it. This is software, right? I mean, like anyone can kind of do anything. Yeah.
First of all, I like eBPF, and I've also used it in very good ways. But I'm pretty certain that most companies you might talk to are not at all familiar with technology because it's pretty low level. What is the most common thing that people are confused about? Do they understand fundamentally what's going on there?
I think some do, and especially like when normally we partner pretty closely with each of the customers that we have, and when we start talking to the engineers, like they'll start to understand it, and they'll ask questions about it, and they'll get to know it that way. Most people, when they first sign up, don't know about it. Like they just see the outcome and that's what they're interested in. But I think in general, like a lot of the time, people are concerned that we will introduce bugs, right, into our stuff, which will then bring down their systems. And I think like that's the biggest misconception that they have, is that fundamentally eBPF is designed in such a way that even if we ship bugs, it's contained inside this VM that the kernel is running, right? So it means that even the worst thing that will happen is that our telemetry will stop being produced. Like we will never impact your production systems because essentially of the way eBPF is designed, it stops us from doing so. I think that's probably the biggest concern.
Okay, and do they understand the metrics? Like, for example, if it says, I don't know, X amount of requests per second, they see maybe timings, do they understand how that is generated, what that really means?
Yeah, some do, some don't. Like that's on us to make that clearer in the platform, I think. So in general, it's all well and good to say, okay, well, this request took this long to process, right? But like what that means is it takes this long from us to read the right request for that request, right? As in like read the right syscall, and then to subsequently process the read of the response from it as well. And like that sort of like additional small overhead on either side, that's probably something that people don't quite understand, yeah.
Okay. And so how do you see things like Prometheus going to the future? Because I know Prometheus was like a big thing, and especially developers liked it, even though most developers I talk to, that at first they like it, but then they'll start to see limitations. Of course, OpenTelemetry has also limitations, but even like many platforms which were very centered around Prometheus are now also supporting OpenTelemetry or even recommending it. Do you see it at some point phasing out, or is it something that will always live next to OpenTelemetry, you think?
I think maybe you will see usage decline slightly, but Prometheus is such a massive ecosystem and it's built into so many different products that it's going to take a while for that to change significantly. And I think like it might be around for a long time as well. I mean, there are plenty of people who use just Prometheus in a standard way, and they're perfectly happy with that system, right? Like they're happy with how that works. And like the whole scraping methodology definitely suits people more sometimes than the push methodology. So I think there's like pros and cons to both. In my ideal world, I think we would standardize on some approach, and it seems like OpenTelemetry is the way that seems to be going. But I think like we'll definitely see Prometheus for a long time. I don't think it's going anywhere anytime soon, but I think we'll start to see OpenTelemetry eat more and more into that market share.
And then, of course, as we are 2025, I have to ask, like, how is AI or LLMs used within your company? Could be maybe you provide something around telemetry, around the usage, or it could be how you maybe consume or aggregate data or present. Is there a use even within Metoro for AI?
Yeah, we actually think that's a pretty big one. So essentially around, first of all, there's like a bunch of different things, but the biggest use case that we found so far is like helping people to automatically diagnose issues. Because we export all this data via eBPF, it's all in the exact same format everywhere, right? So it means that we can write very specific algorithms and allow AI to interact with it in a very standardized way, which means that it can very easily spot problems or essentially failure modes in a lot of like Kubernetes clusters. So the biggest sort of use case that we find is allowing AI to essentially look at this data stream and then, okay, well, this data stream is anomalous, then it can start to investigate individual components. So it can look at traces, it can look at logs and drill down into the root cause and then try and show you that root cause as an outcome, if that makes any sense.
Totally makes sense. But for example, where I did see something like that used is in Sentry, where they try to automatically give a possible solution about what could be the issue. And I found at each time it was just saying some very vague stuff which didn't apply at all to the problem. Of course, that is like already more than a year ago, which is like a century in terms of AI. So I wonder, how is the success rate there or the satisfaction rate with those kind of diagnoses?
Yeah, so this is anecdotal and like we've now rolled it out as now GA and like we're seeing pretty good success rates. It's not perfect by any means. Like no AI system will be perfect, quite frankly. But it's been like 80% plus have been like positive. Essentially, it's like a little thumbs up, thumbs down, like whether this was useful or not. There's been 80% thumbs up, which I think is pretty good. And then we also go a little bit further as well. So it's like we also actually produce PRs as well. So in this situation, it's like if we find an application bug and like we know how to fix that, we will actually raise a PR as well. And like those have been getting pretty high success rates, similar to the actual thumbs up, thumbs down ratio of the investigation itself.
But that means that next to the fact that you ingest their data, they also give you access to their code repository.
Exactly. You can put it as an annotation on your Kubernetes pod. This is the repository where where the code for this service lives, and we will go and inspect that code. So we support like GitHub and GitLab. So as long as you have it hosted there and we have an integration that you've set up between the two, we can look at the code as well. Like some people choose to do that, some people don't. It sort of depends on like what your standpoint is on the security and like whether you want us to look at your code.
Okay, totally got you. And then I mentioned Sentry, and so Sentry was traditionally used for like based on your logs, it raises issues and it might also group them together. You can easily filter them. It can create alerts. Then they also ventured into spans and traces. I don't think they do metrics. I might be wrong. But still there's a lot of overlap with what Metoro is doing. And I feel there is very little that you would need to fully capture what they capture. Is that something that you would ever consider? Because otherwise I feel it now means that even though someone might be a Metoro customer, they might still need something like Sentry for all the maybe like automatic bug tickets or based on their logs and those kind of things, maybe linking to the metrics. And actually you even have a lot more data than they have because you also have the entire eBPF things and what else.
Yeah, so I think like that's where we want to go fundamentally. It's like we want to be able to give people this holistic view of their entire system and like they integrate the code, everything like this. That's where we want to go. I think with Sentry, like you need to actually implement it inside your code, right? They have an SDK that you need to instrument your code with, as far as I'm aware.
Yeah, but that's kind of what you have Opentelemetry for, right? Because they don't do that much more than what Opentelemetry does. It's basically just about exporting logs, adding some metadata to it, which you kind of get for free already with Opentelemetry, I would say.
Exactly, yeah. And I think like we have all the sort of data sources we need to do this effectively. So yeah, we have logs, we have the metrics, we have the traces, and now we have the code. And I think like they're really profiling as well. That's an interesting thing to talk about. But yeah, we have like those 5 pillars, I think. And as long as we have those 5 pillars, we can do a pretty effective job of fixing things.
Okay, very nice. Yeah, I mean, we can definitely talk a bit about profiling, which again, it depends a lot on the language and about the technology used, of course, because it used to be a lot simpler when everything was single-threaded or where everything was using OS threads. But if you look at something like Rust, and it's not just Rust, many modern languages, they manage their own threads. And then you have very language-specific tools to really inspect what is happening within these asynchronous like tasks or, well, there's all kind of terminology used, but fundamentally it's all like things that the OS doesn't manage. And then I wonder how easy it is to really support all these different things effectively, because if you don't, then you do miss a lot of potential like data points, I would say.
100%. I think like really like, so with anything that's native, so like yeah, Rust, C++, anything compiles down to a binary, as long as you include debug symbols, it tends to be pretty good. You're right on the async front. Yeah, that makes it much harder to actually see, like, cause the whole point of a profile, right, is you see this thing calls this thing, and this thing calls this thing, and you see that stack trace effectively. Async makes that much harder, so you'll see, okay, well, this particular function call was taking a long time, but where that was called from, you don't really know.
Yeah, exactly. So allocations you will of course still see, but like you might not at all see like why some kind of task is stuck for a long time, or why is it being called all the time, or I don't know.
I think so, yeah. And I think like that's an interesting problem in ASIC programming in general. I think like maybe there's a good solution to that, but I don't know what that is. So with the more synchronous stuff, it tends to be much easier. Yeah, so like that's for the native side, and then for like the non-native side, so things like like Python, Java. There are some interesting solutions there. For Python, what some people do is that they essentially see, okay, well, what's running here? And then they look inside the VM to reconstruct the actual stack trace. That's interesting. But like for the most part, a lot of the time there, like you're hooking into the underlying like library implementations of these things. So like in this case, like if you're running from Java, you'd want to take like, a Java profile, and then you have it integrated. So you actually integrate the language level for most of those things.
Okay. And so I know Metoro you can do fully managed by you, but is it also something you can self-host?
Yeah, we do. So like we recommend the SaaS version for most people just because it's the easiest thing to install, but you can self-host it. It's a bit more work, but it's definitely doable.
And so what are the different like payment models? Are there different tiers, different ways to pay, different ways to be a Metoro customer?
Yeah, so it's pretty simple. Like we try and keep it as simple as we can. So you normally pay a per node fee. So like if you have, let's say you have a Kubernetes cluster with 20 nodes, we charge $20 per node. So you'd pay $400 a month at that point. And then that gives you 100 gigabytes of ingest per node. And if you use more than that ingest, you then pay 20 cents per gigabyte ingested. Because we need to basically cover our different dimensions there, because we pay for ingest effectively.
And is that same for self-hosted versus fully managed?
Yeah, for self-hosted, no. So you don't pay for any data. You just pay the flat fee for the management of the nodes. Yeah, because we no longer have to cover that cost.
Okay, I understand. And we talked about a lot already, but is there something else you would like to talk about or plug into the podcast?
No, I mean, I think it's been good. I wish more people started, with tracing. I think it can be really interesting. I think it can help you debug a lot of stuff that you're otherwise struggling with.
And let's say someone is still not convinced of like why they would want this. Like how could you, as a kind of elevator pitch, convince them to become a Metoro customer, even if just on trial?
You can just try it really easily. It's a 1-minute install. It uses eBPF, so you don't have to do anything. So you can install it, and if you don't like it, you can uninstall it. 1 day later, 2 days later, it's all free for the first 2 weeks. You can try it, and if you don't like it, you can leave.
All right. And then I've seen you very engaged in some customers where you even join their chat, community channel or whatever. Is that something you offer as an extra, or is that just something you do for new customers?
Yeah, that's for like only customers. So if you come with Metoro, probably I'll be in a Slack room with you. We just, especially like at this stage in the company, we want to talk to all of our customers, want to get as much feedback as we can from everyone. So I'll be there. Any questions you have, I'm there to help you out pretty much directly. Maybe a few other engineering members coming in as well, but for the most part, I think you'll be talking directly to me.
Very cool and very personal. I like it. And I also like how you are based on open standards. That has a lot of advantages, and I hope that people appreciate that, because there are not enough commercial activities that do that. Okay, so thank you very much for coming, and I thank you for your time, Chris.
Thanks, I appreciate it, Glenn. It was great chatting.
Netstack.fm is brought to you by Plavayo, building secure, open, and resilient infrastructure with Rust, protocols, and purpose. This show is also made possible by Rama, the open source networking framework. Plavayo offers service contracts and welcome sponsorships to keep building and supporting its ecosystem. The theme music of this podcast was composed by DJ Mailbox. If you enjoyed this episode, don't forget to subscribe on your favorite podcast platform and leave a 5-star review. It really helps others discover the show. Thanks for tuning in. We'll see you next time for the next handshake.